Hello everyone, and welcome to OneClass. My name is Jeff Krause. I have a PhD in physical chemistry, and today I'm going to go through a few undergraduate, high school level physics questions. So here we have our first one. Four long parallel wires each carry 2 amps in the same direction. They are parallel to the z-axis, and they pass through the corners of a square of side 4 centimeters positioned in the XY plane. What magnetic field does one of the wires experience due to the other wires? So we have 1, 2, 3, 4. So this is our square. Of side length 4 centimeters. And so it says they're parallel to the z-axis, so this here is our XY plane. And from the right-hand rule, the z-axis will be out of the page. All right. So if we're trying to figure out the B field at 1 due to the other 3 wires, we can use our expression for the B field due to an infinite wire, but remember that B is a vector. So this gives us our magnitude, but we also need our direction. And our direction comes from our right-hand rule. So the B field due to, if we look now, we're going to focus just on the 1 wire and get the B field due to 2, 3, and 4 on 1. So if we're looking, and right now I'm just going to do B to 1. So my magnitude is mu naught I over 2 pi r. My r is 4 centimeters. My I is given in the question as 2 amps. So my B21 is 4 pi times 10 to the minus 7 times by 2 amps over 2 pi times 0.04 meters. As 4 centimeters is 0.04 meters. Okay, if we do that out on our calculator, we get 1 times 10 to the minus 5 Tesla. But now we need direction. So remember that we use the right-hand rule here. So we've got 2, 1, there's our R. And we're talking about from 2 to 1, so we would put our thumb in the direction of the current, and our fingers would curl in the direction of the B field. Okay, so now picturing our thumb going out of the page, we see that the B field would curl this way, so this is the direction. And in fact, at R, it's going to be straight down. So looking at our X, Y, our B21 is then minus 1 times 10 to the minus 5 Tesla in the y hat direction. So that gives us our full directionality there. Okay, now we can do 4 pretty readily as well, right? So 4 is going to be pretty much the same as 2. So B41 magnitude is mu naught I over 2 pi r, which is 4 pi times 10 to the minus 7. I should have put some units on there, but that's going to be just Teslas, meters per amp, times 2 amps over 2 pi times our 0.04 meters, which is again 1 times 10 to the minus 5 Tesla. But now our 4, 1, applying right-hand rule again, with our thumb pointing out of the page, then we get that the B field will be in our negative x direction now. So B41 vector is minus 1 times 10 to the minus 5 Tesla in the x hat direction. Okay. And then, so 3 is now the trickier one. Okay, and now we've got a sides of 4 centimeters. So, so our R here is square root of 4 squared plus 4 squared, which comes out to 5.657 centimeters, or 0.05657 meters. And so we can easily solve for our magnitude as mu naught I over 2 pi r, 4 pi times 10 to the minus 7 Teslas meters per amp onto 2 amps over 2 pi times 0.05657 meters, which comes out to be 7.071 times 10 to the minus 6 Tesla. Now our direction is going to be a bit trickier. So we can see that here's 3, here's 1. Again, using right-hand rule, it's going to be perpendicular to the R and pointed downwards in this direction. So our R vector we can figure out, and this is going to be our B41 hat. Our unit vector in our B41 direction is going to be that way. And so we know that, B31, our B31 hat is going to be, so the right-hand rule really expresses that it's going to be K hat cross R hat, R31 hat. And, right, so if we figure out what R31 hat is, which is R31 vector over R31 magnitude, which is 4 centimeters in the minus 4 centimeters in the x hat plus 4 centimeters in the y hat. Recalling our axis system. Over our magnitude, which was 5.657 centimeters. This comes out to be minus 0.70709 x hat plus 0.70709 y hat. And we can, so we can easily get our B31 hat now as k hat cross with this expression. And the way I remember how the unit vectors all cross product is pretty easy. So x hat cross y hat is k hat. And then it rolls through. So y hat cross k hat is x hat. And k hat cross x hat is y hat. And then if we want to switch them, it becomes negative. So y hat cross x hat is minus k hat. K hat cross y hat is minus x hat. And x hat cross k hat is minus y hat. So if we look here, this is going to be minus 0.70709 k hat cross x hat plus 0.70709 k hat cross y hat. And so we can find these in here. So k hat cross x hat is y hat, and k hat cross y hat is minus x hat. So this is minus 0.70709 y hat, and then minus 0.70709 x hat. So our B31 vector is our B31 magnitude times our B31 unit vector. So we get 7.071 times 10 to the minus 6 Tesla times minus 0.70709 x hat minus 0.70709 y hat, which comes out to be 5.00 times 10 to the minus 6 Tesla times minus x hat minus y hat. All right, so now our B field at 1 is just equal to the sum of these. Which is minus 1 times 10 to the minus 5 Tesla y hat minus 1 minus 5 times 10 to the minus 6 Tesla x hat plus y hat. So I just took the negative out of there. And minus 1 times 10 to the minus 5 Tesla x hat. So this comes to be minus 1.5 times 10 to the minus 5 Tesla x hat minus 1.5 times 10 to the minus 5 Tesla y hat. And then if we want to know the magnitude of our B field at 1, well, that's just the square root of the component squared. And I've gotten rid of the negative sign, as negative, the square of a negative is a positive. And that comes out to be 2.1 times 10 to the minus 5 Tesla. And so then there's our B field at 1. 2.1 due to the other wires. And because of the symmetry, the magnitude would be the same, although the directionality would be a little different. So for all the other wires. So then there's our total B field. And all right, so checking to the solution given. So they just add it all up and get 2.7. So the discrepancy here is because they didn't treat them as vector quantities properly. So magnetic field is a vector and needs to be treated as such.